We have Chapter 10, Section 4, Compound Events. Essential question is, how can you use relative frequencies to find probability? So we have a couple of vocab words today, so we're just going to break them down one by one. First one is a sample space. The sample space is the set of all possible outcomes of one or more event. You can use tables or tree diagrams to find the sample space of two or more events. So in this one, we're going to use a tree diagram. This is going to be the only tree diagram that we use today. It says you randomly choose a crust and salad pizza. Find the sample space. How many different pizzas are possible? So this is the main question we are trying to answer. How many different pizzas are possible? If you notice here on our left side, we have our different type of crust, then our different type of styles. So I want to know, with these 6 options, how many different pizzas are possible? Okay, so we're going to draw a tree diagram. So first, I have 2 different types of crust. I have thin crust, and I have stuffed crust. And we're going to space them out a little bit because we are going to make a pretty big tree diagram. So of those 2 crusts, if I order thin, I can order 4 different styles. So I'm going to draw 4 different lines. So one of my styles is Hawaiian. One of my styles is Mexican, pepperoni, and veggie. If I get a stuffed crust, my 4 options are the same thing. I have Hawaiian, I have Mexican, pepperoni, and veggie. Okay, so these are all my outcomes. So I want to kind of put those together and write a final answer. So one of my outcomes is a thin Hawaiian, a thin Mexican, thin pepperoni, and thin veggie. So I have my 4 thin crust pizzas with 4 options. My stuffed crust options are stuffed Hawaiian, stuffed Mexican, stuffed pepperoni, and stuffed veggie. So here's my tree diagram. Like I said, as you notice, it does take a lot of time, but I do get to my outcomes. So my outcomes are all of these following different types of pizzas. I have my thin crust options here. I have my stuffed crust options here. So the answer is how many different pizzas are possible. I would just count up my outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So my answer is 8 possible pizzas. That would be my final answer. Now, we do need to think of an easier way to do this because we're not going to do a tree diagram every time. It's going to take us a long time, and it's also going to be a lot longer of a diagram the more options that we have. So our next vocab word kind of covers this. Our next vocab word is the fundamental counting principle. This is another way to total the number of possible outcomes. So it says an event M has M possible outcomes, an event N has N possible outcomes. So instead of using a diagram, we're going to use this fundamental counting principle and multiply those 2 together. So let's kind of see how this looks in an example. It says, find the total number of possible outcomes of rolling a number cube and flipping a coin. Now, we can use a tree diagram, that's fine, but just giving you a heads up, it's going to be a lot longer method. So this one's going to kind of take out that time and help us get to our outcomes a lot quicker. So our first event is rolling a number cube. Let's just kind of list the numbers list my outcomes of rolling a number cube. Once again, we're 1 through 6. Event 2, it says flipping a coin. I only have two options when I flip a coin. I either get heads or I get tails. Those are my only two options. So what I'm going to do, I'm going to count the number of outcomes on both and multiply them together. So for the cube, there's 6 possible outcomes. For flipping a coin, there's 2 possible outcomes. I'm going to multiply them together, which gives me 12. Alright, so my answer is 12 possible outcomes. And you are already done. It's getting a lot quicker than using a tree diagram. So if we go back to our pizza question, if I have 2 different types of crust and I have 4 different styles, I would do 4 times 2 to get 8, and we're already to our answer. So once again, using the fundamental counting principle is going to be a lot more efficient. If I go back to the back, question B, how many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? Okay. So once again, we're going to use the fundamental counting principle. I have 3 different things going on: shirts, jeans, shoes. I'm going to take those 3 numbers and multiply them together. I don't have to list all their options because it doesn't even tell me what color shirts there are, what color jeans, what color shoes, but I do know the amount that is happening. So 4 shirts times 5 jeans times my 5 shoes. Multiply those together. 4 times 5 is 20. Bring down this 5. 20 times 5 is 100. So just with these different numbers, there's 100 different outfits, because that's what it's asking. 100 different outfits are possible. Okay. Again, just from using the fundamental counting principle. Now, if you notice on the bottom here, you do not have practice problems. We are actually going to keep going on with this lesson because it's a little bit longer. Last vocab word is a compound event. That consists of 2 or more events. As with a single event, the probability of a compound event is the ratio of the number of favorable outcomes to the number of possible outcomes. So we're still going to look at using probability. We're now looking at 2 separate events. And we're going to see if we can find the probability for those 2 events combined. So it says, what is the probability of rolling a number greater than 4 and flipping tails? So first, I want to write the probability greater than 4 and the probability of flipping tails. So first, let's kind of get these 2 fractions. So if I have a dice and I want to get the probability of rolling a number greater than 4, that would be 5 and 6. Okay, so that would be 2 out of 6. And I'm going to simplify that to 1/3. So that's part of my answer. My other one, what's the probability of flipping a coin and getting tails? There's 1 tails, and there's 2 options. So 1/2. So my 2 outcomes are 1/3 and 1/2. But I want to know the possibility of getting a number greater than 4 and then a tail. So what I'm going to do, I'm going to take these 2 numbers, these 2 probabilities, and I'm going to multiply them together. All right, so when I do that, I'm going to find out the total probability of rolling a number greater than 4 and then getting your tails. So when I multiply those 2 together, 1 times 1 is 1, 3 times 2 is 6. My final answer is 1/6. So I have 1/6 of a possibility of rolling a number greater than 4 and getting tails. Let's look at question B. It says you flip 3 nickels. What is the probability of flipping 2 heads and, I should say, 1 tails? Sorry about that. Okay, so let's look at it. So probability of getting heads and I'm going to do that twice because it says 2 heads. And then 1 tails. So if I'm looking at this particular problem, the probability of flipping 2 heads and 1 tails so the probability for 1 heads is 1/2. Probability of flipping 1 heads is another 1/2. And then the probability of flipping tails is 1/2. So if you notice, I have 3 halves right there. So what I'm going to do, I'm going to take all these fractions and multiply them together. 1/2 times 1/2 times 1/2. Okay, so the chance that I'm going to get 2 heads and 1 tails in that specific order, if I flip a coin, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. So I have 1/8 of a chance of getting 2 heads and 1 tails. Now once again, you don't have any practice problems. Tomorrow when you come into class, we're going to kind of talk about a lot of things. We're mainly going to focus on compound events, but there was a lot to cover in this video, and I wanted to make sure you had all your notes done. If you have questions about anything, please make sure you're writing them down, and we will get them answered tomorrow when you come into class.